A quick one on this. Question 24. A fair dice is thrown once. Find the probability of obtaining an odd number or a prime number. Or here means union. So if I can check, I can say that odd number, the set of odd number is going to be, or let's say, if we can first indicate the sample space. So sample space as U is 1, 2, 3, 4, 5, 6. These are the various sample space we can get on the dice. Then we can find number of U. How many elements are there? 6. Then let's say we are using E to represent what? Odd numbers. So if E is the odd numbers, among here we have 1, 3, and what? 5. So number of E will also be equals to what? 3. Then let's D be the set of what? Prime numbers. So we can now have our set of prime numbers from the same set. 2 is a prime number, 3 and what? 5. So number of D also equals to what? 3. Now, we can solve it in a way by which we combine them together, listening to the concept of union, as in OR. So I can say that odd number or union is talking about the E union D. Let me put it this way. So E union D, putting the set E and D together, that is, I'm having 1 here, 2 there, 3, 3, and we have 4, 5. So I can say that number of E union D is going to be what? 4. So I now have the set consisting of the odd number or prime number. Therefore, I can say that probability of E or D equals to the number, which is 4, divided by the total, which is going to be what? 6. Common factor of 2 will give us our answer to be 2 on 3, which is going to be the option what? C. Now, without taking this route, we can also take it as mutually inclusive, as in we are going to have the probability of E union D equals to probability of E plus probability of D minus probability of E intersection what? D. So I think I need to first find the intersection. I can find it here. The set of E intersection D, combining the set E and set D, what they have in common. I think they have 3 and they have 5 in common. These are the set, right? So I can easily say that, where can I put that? The number of E intersection D is going to be what? 2. So if I'm following this, the probability I'm looking for is probability of E, meaning number of E, which is 3 divided by the total, which is 6, plus number of D, which is 3 divided by total minus the intersection, 2 out of what? Total. Remember, you're having the same denominator, so you add the numerators, which is this plus this 6 minus this 4. So you still have 4. 4 out of 6, which is still 2 out of what? 3. So I can say that alternatively. So I guess we can use it as a union, which means or which means union. Or we use a mutually inclusive, seeing there is a number that belongs to the two sets. All right. I believe this is clear. Like, share, comment, and come back to question 25.